Okay, page 38 of your workbook, 3.2.4, vertical and horizontal lines. So we've talked about this before, but let's just review it. Graph the line. So if I'm given a line y equals -2, you might say, well, okay, well, where's the x part? Well, if I were to just make a t-chart, for instance, and I said x, y, and every time my rule says y equals -2. So when I plug in, so I pick a value for x, I pick 0. And what does my rule say? Well, it says y is -2. Doesn't matter what x is. And say I pick 3. It says y is -2. If I pick -10, it says y is -2. So it's -2 no matter where I put it, no matter how I slice it. So I just can plot that. So -2 when x is 0. If x is 3, it's -2. If x is, a million, it's -2, so on and so forth. So anywhere on this line, and it will be -2. Okay, so still I can plot a couple of points or label a couple of points. But really on these ones you kind of don't need to. So that is it. My slope for that, if you remember, I would have no vertical change. So if I think of it this way, M being change in y, or my vertical change over my horizontal change, I would have 0 over whatever it is, for this case, 1, 2, 3 equals 0. So remember, for horizontal lines, slope is always going to be 0. It's just a flat line. Now when we have x equal to 3, it's the same kind of thing, except we are going to be saying, like, no matter what I pick for y, if I pick 0 for y, x is 3. If I pick 5 for y, x is 3. If I pick -1, whoops, -1, that's going to go over here, for y, x is 3. So x is always 3 no matter what. So x being 3, but sometimes it just helps you to plot. 3, 0 is right there. Then we have 3, 5 is up here. And then connect the dots. So a lot of times it just helps people to really just put something in and make it a little more concrete. And that's fine. After a while, you'll get to just sketch these. You won't really need to plot anything. And if I look at the slope, again, being change in y over change in x, this time I have no horizontal change, but I do have a vertical change, and I can just pick any distance between these points. So I'm going to pick the 5. So 5, or it could be whatever, a million, over no horizontal change, which is 0. And remember, that is undefined. So slope is undefined. You could say DNE, I think, on your electronic homework. I prefer undefined. Makes more sense to me. But vertical slopes are always, or vertical lines are always going to have no slope. They're undefined. So I hope that helps. Just these are really ones that people tend to switch up very easily. But think, where is that 0 sitting? Is it, if it's in the numerator, if you have no up down, then that's 0. If it's in the denominator and you have no side to side change, then that's the undefined situation. Now let's look up at point slope formula, or form. Sometimes we usually just call it. So I'm going to show you how this is derived based on the slope. You can kind of see the slope in there. So I wrote down slope, and instead of writing y sub 2 minus y sub 1 x sub 2 minus x sub 1. I'm just doing it to match here, saying that I have a generic y minus my first y, a generic x, no subscript, minus my second x. I mean first x. So sorry about that. Sometimes my hand hits the Zoom. So now to solve for y minus y sub 1 like we have here, we simply would just clear the denominator, multiply both sides by x minus x sub 1. That's like in parentheses. And then there we have it. We have x minus x sub 1 times m, and if I just commute that and put the m to the left, equals y minus y sub 1, then you can see these are really the same. If I were just to switch around, y minus y sub 1 equals m times x minus x sub 1. And there we have the match. So that's given that we have slope m on the line, and this point x sub 1, y sub 1 is on the line. Now this will work also if you have the y-intercept. It's just that when you plug in for that x value here, it'll be 0, so it just comes out pretty nicely. These are what you want to use when you have a point, some random point, or really any point, because you could do the slope intercept. But when we don't have the intercept, we really have to use this one, or there is another method that we can do that I'll show you later. I don't want to do that quite yet. Just focus on this right now. So we're going to label this x sub 1, y sub 1, and then slope negative 2. That means m equals negative 2. So use the point slope form to find an equation of the line with slope negative 2 and contains the point negative 3, 5. So always write your formula. If it's not there already, it is there, but I'm just going to write it bigger. And now we're just going to plug stuff in and go ahead and simplify it down to y equals mx plus b form. And then we will be able to pluck out what the y-intercept is. So I'm going to plug in y sub 1 is 5, and slope is negative 2, and x sub 1 is negative 3. Notice the subtract here I wrote in red is the part of the form, and then x sub 1 is negative 3. So I just want to be clear with that, because this is going to make plus plus, right? So now we have y minus 5 equals negative 2x. We have to distribute. And then we have negative 2 times the 3 is going to be negative 6. And just keep simplifying. We're going to add 5 to both sides here. I should be really good at this by now. Y equals negative 2x, and then minus 6 plus 5 gives me a minus 1. And there we have it. That's our equation, but it does ask, it just says find the equation with the slope. Once in a while you're asked to just leave it in point slope form, maybe in your electronic homework. I don't usually do that, but once in a while just keep in mind. We can also figure out what the y-intercept is here. And it's the point 0, negative 1. Notice I'm writing that as a point. And then again, we could check. We can verify that it works. We could take this point, negative 3, 5, and put it in there. So we can say, now this one, we don't want to plug into anything. We don't have an original equation. We want to plug into the thing we derived with our original info up here and see if we have a match. So -2 times the -3, and then -1. So I would get 5 equals 6 minus 1. And yes, 5 equals 5. We're good there. Nice. Okay, so that's our answer. I'm just pointing out what the y-intercept is because a lot of times you'll be asked to find that or to state that once you get this far. So I'm going to go ahead and show you an alternate method to figure out what your y-intercept is and then make your equation. So you may not see this in your book yet for a while, but eventually it'll probably crop up. So we can actually just start with y equals mx plus b. A lot of people really like this method. And we can plug in our info. Plug it all in. All of it. Except b. Because we don't know b. B is a question mark. But we have a y. Right? We have a y is 5. We have that m is -2. We have that x is -3. We just don't know b. And then we're going to solve b. Okay? So we have 5 equals 6 plus b. Subtract 6 from both sides. And we get -1 equals b. So now we know we can plug back into the generic form. And we can write the y as just plain y equals the m we do want to sub in as our -2, right? X is just the plain x. And then we add that -1 plus b, but it's minus. And we get the same answer. Now, mathematically, that's easier, I think, in the long run. Like, it's shorter and kind of nice, but conceptually and trying to kind of wrap your head around that might be a little bit tricky. You may get a little lost in your train of thought. So you could try it and see how you like it. Can ask questions about it. I might put up like an activity about that with some little comparisons. There's like a worksheet that I have, but we'll do that a little bit later. That's kind of fine tuning. And when you get to your next class, which for you guys will be Math 99 now, it used to be 140, but 99. We just changed the numbering. So we'll have you take that and we'll work on that in that course as well. Have a great day.